So this in this session we'll solve typically three questions. So at the end of each question, I'll tell you how we can solve easily rather than following a very long procedure. So I hope this session will help you a lot. So let's begin that. So can anybody respond? Are you able to see my slides here?
No, sir.
No.
No, sir.
Wait. Share. Is it visible now?
Yes, sir.
Okay. This is a session two. So as I already mentioned that today we will uh, talk about unit hydrograph. So let's begin that. So before starting, I'll mention this way. So this session we will keep it more interactive. So in between, I'll wherever you feel like to stop me, you can stop, and we can discuss if any point is not clear. So yeah, don't think it is like a lecture and this thing. So we can openly discuss and then we can interact more. So let's start with this. So, so yeah, let's start with the unit hydrograph. Consider a watershed. So imagine this is a watershed outlet. So this dots represents the control section. So this is watershed. So sorry, this handwriting is bad. I'll improve slowly. Yeah. So imagine there is a IT intensity of precipitation which is falling uniformly on entire watershed. So I mentioned uniformly. So and this IT precipitation intensity is constant for excess rainfall duration. Okay, so these two words are very important. Suppose imagine there is a IT precipitation falling uniformly on the entire watershed, and this particular precipitation will result into a hydrograph. Will results into an hydrograph at the outlet. For example, if this IT is 1 by T centimeter per hour, more essential that is, let's say 1 centimeter of excess rainfall in T hours. In this, let's assume this is IT which has a constant intensity of 1 by T centimeter per hour per T hours. If this IT is 1 by T, then this particular hydrograph will be called as unit hydrograph. So there is a textbook definition also. but that won't give the actual essence. So I'm making it more simple manner. So imagine there is a uniform intensity of rainfall falling on the watershed uniformly throughout this excess rainfall duration T. That will result into a direct runoff hydrograph. That is nothing but a unit hydrograph. See, note down, unit hydrograph is nothing but a direct runoff hydrograph. So this one time they have asked for one more question, direct runoff hydrograph with excess rainfall of 1 centimeter. So let me ask you in this way: what is excess rainfall here? What do you mean by excess rainfall? So excess rainfall is nothing but the amount of precipitation is available for the runoff after meeting its losses. What are the losses? Infiltration, evaporation, depression, retention, storage, all these losses. So what is the amount of precipitation available for the runoff after meeting its losses is called excess rainfall. This excess rainfall will result into the hydrograph. Suppose if this excess rainfall is 1 centimeter, that particular direct runoff hydrograph can be called as a unit hydrograph. Okay, I hope I am clear. Let's read this more formally. So it was first proposed by Sherman in 1932. So the unit hydrograph was originally named as unit graph of watershed. How we can define it is a, as I mentioned, it is a direct runoff hydrograph resulting from, so leave the cinches. This was like in US they follow FES system, so in but in India we follow SI system. So let's read in this way. So this is a direct runoff hydrograph resulting from 1 centimeter of excess rainfall generated uniformly over the entire watershed. It can be called as a watershed also, at a constant rate for an effective duration. This duration can be T or D. Example, any duration, maybe 1 hour, 2 hour, all these things. So let's read once again. So unit hydrograph is nothing but a direct run of hydrograph resulting from 1 centimeter of excess rainfall generated uniformly over the entire drainage area at a constant rate for an effective duration. See, if we clearly observe in the definition itself, we made so many assumptions. What are the assumptions? Very first assumption is that the excess rainfall generated uniformly. See, if you consider the very large watershed like a Ganga or a Godavari, so it is actually, it has a diversity, diverse land use patterns. So if we cannot assume that whatever the stream flow available at the mouth of the Godavari or Ganga, it is generated uniformly over the entire watershed. It is not. So and similarly, this precipitation intensity we assumed is a constant rate, but in a practical case, so the intensities varies with respect to the time. Suppose now the intensity may be 10 centimeter per hour, after 1 hour it may decrease, after 15 minutes it may increase. So like that we made so many assumptions to form this particular unit hydrograph. See, this unit hydrograph is developed to determine the stream flow hydrograph for any. Suppose if you know, it is nothing but a simple linear model. It is derived. So the main purpose, like why this unit hydrograph was developed, because that before 2000s we don't have a stream flow gauges. Stream flow gauges used to measure the stream flow in the rivers. So in that case, we only have this precipitation gauges. Suppose we know the precipitation amount in a watershed, then how much stream flow it will be generated at the catchment outlet. This is we want to know. For that, so this Sherman and other group members, they have developed a simple linear model that can be used to derive the hydrograph for any amount of excess rainfall. So this point will be get cleared while we solve the problems. So for a sake, just keep it in the mind. Yeah. So these are the following basic assumptions. that they have assumed while developing this model. One is the constant density, I have already mentioned, like IT. So they assume that it is a constant over a T-hour duration. To our effective duration. And second, what is the second point? They assume that it is uniformly distributed. It may not be the true in all the cases. So these are other assumptions can be seen. One is the base time of the DRH resulting from excess rainfall of a given duration is a constant. So all these points are trivial, but only remember these first 2 points. These are the important points. So sometimes you may expect some theory question by twisting these two assumptions. So keep this definition in mind as well as these two definitions. So yeah, and this is another way to say unit radiograph is nothing but a lumped response. I have already shown here. Imagine this watershed as a linear system, and whatever the variable inside the watershed we won't be able to consider. We will simply assume that IT will be converted with some function of qt. So whatever input, it will be converted to output with some linear transformation. That this is a little advanced, so currently you can ignore. Yeah, yes. Let's keep these points in mind. Under the natural condition, the above assumptions cannot be perfectly satisfied. See, although the model was originally devised for the large watershed, but it has been found applicable to very small watershed from less than zero point 0.5 hectare to 25 kilometer. So this was one of gate exam gate question 1 year, like for 1 mark. So what is the limit? What is the watershed limit we can apply the unit hydrograph? So keep this 25 kilometers per in mind. So because why this model has a limitation? Because we assume that rainfall is uniform and it has a constant density over a effective duration. So these two assumptions often fail when we model very large catchment for a very long time. Like let's say we are using this photograph for a 6 hour duration storm over a, like a 10,000 kilometer square watershed like a Godavari or Ganga. In those cases, if we cannot apply this unit photograph directly, so we may even need to divide the entire watershed into sub catchments. Okay. Yeah, so I'm running bit fast because we have some few questions to solve. There we'll spend good amount of time. Okay. Yeah. So the two basic assumptions constitutes the foundations of unit radiograph theory. One is the time invariance, another is linear response. Okay, so let's see what is this time invariance and linear response. Suppose you have developed one unit hydrograph for a watershed. Let's say, so the very first basic assumption is the direct runoff response to a given effective rainfall in a catchment is time invariant. This kind, so please kindly mute yourself. Okay. This implies that the direct runoff hydrograph for a given effective rainfall in a catchment is always same irrespective of when it occurs. So let's imagine you have developed this unit hydrograph in 2005. Let's say after you develop this unit hydrograph for any catchment, the major deforestation happened in your that particular watershed. So do you think this catchment will respond in the same way as before? No, it will change because this deforestation will increase the runoff availability. So the volume of water available for the runoff will be more. Okay. And as suppose like for example like a major urban settlement happened in the watershed, in that case also you will have more amount of water available than the before. But all this practical things we'll ignore, and we assume that suppose if we develop a unit hydrograph and one time it will be same even if we use for the other like at 2010 or 2022 for the same effective rainfall. So clearly look at this picture. Let's say in 2000 this is a watershed. This is a watershed, and we have developed this direct runoff hydrograph for this effective rainfall of 5 centimeter. Suppose though between 2000 and 2005 there is like major deforestation and urban settlement happened, but we assume that for the same effective rainfall of 5 centimeter, this direct runoff will holds the same even for 2010 also. This under this assumption, these assumptions make us easy to model the stream flow in ungauged basin. So, what one can question that this assumption is invalid in many cases as true, but when we look at the long term response, it will be valid. So suppose though there is a deforestation in the some part of the catchment, maybe the some part will be considered as a vegetation, like a paddy, where this will hold the water for a longer time. Though there is a quick runoff here, but there is a delayed runoff here. So on a overall, at the catchment outlet, this response will still holds true. That is the essence. So second one, linear response. Yeah, this is important one. Based on this particular assumption only, we will solve all the questions. Suppose imagine this is a output and this is an input. Let's say we have given as x1t as an input, which resulted y1t. So here y1t can be considered as a q stream flow. Maybe x1t can be considered as a p. Let's say you have given p amount of input which resulted q stream flow. I already shown here catchment. Suppose you have given p input which resulted q output. Suppose similarly you have given q2, let's say p2, this is p1, which resulted q2, q2t, here q1t. Okay, so for a different excess rainfall depth, the response from the catchment will be different. Okay, so the direct runoff response to the rainfall excess is assumed to be linear. This is the most important assumption of the unit hydrograph theory. So when we say linear, what does it mean? Let's say x equal to 3y. Suppose let's say when we take y equal to 1, how much will be the x? X will be 3. When we take y equal to 2, x will be 6. In the similar manner, if we take y equal to 10, x will be 30. So this we assume that input and output are linearly associated. Okay, so which this makes us easy to calculate the unit hydrograph by knowing suppose if we know 1 hour UH, so how we can calculate the 2 hour UH? So by because of this linear assumption only. Okay, so that you will get a clear while solving the question. Okay, so linear response means that if an input x1t causes an output y1t and an input x2 causes output of y2, then an input of x1t plus x2t will cause an output of y1t plus y2t. So what are the two assumptions? One is time invariance, another is a linear response. See, these two assumptions are, are practical and it is very important for solving the questions. So you already seen some few other examples which are used to develop the definition, but these two assumptions are used to develop the theory, mathematical equations. Okay, yeah, let's solve one question so that you will get a clear picture. So so given below are the ordinates of 6 hour. So note down 6 hour unit hydrograph for a catchment. Calculate the ordinate of DRH due to excess rainfall of 3 centimeter occurring in 6 hour. Okay. So here see, here they have already given the unit hydrograph ordinates. So imagine, suppose let's say This is unit hydrograph. And what is the duration? 6 hours. And what is excess rainfall depth? 1 centimeter. Okay. So this is a D.
EduUdr.
Yeah. You have any doubts? Yeah. This is a DRH resulted from 1 centimeter of excess rainfall. Suppose now we want to calculate DRH of 3.5 centimeter excess rainfall depth. So as I have shown in the previous slide, we make the assumption that these are linearly associated, that IT and X1T and Y1T. Suppose this will be like one for 1 centimeter, this is a hydrograph. Then for 3 centimeter, how much will be? All the ordinates will be simply multiplied with the 3.5 centimeter. So let's see that how we can do. So see here. So this is the time 0, like at a 0 at 3, 6, 9, 12. These are the time hour times in hour. Okay. And these are the corresponding unit ordinates. Okay. Now what we did was that we just simply multiplied with the 3.5. It will be 0. So 25 into 3.5 will be 80.87.5. So in the similarly we calculated. So let's plot how it may look like. This is for 1 centimeter DRH or UH. Now we just multiplied the same with the, sorry, okay, this is 3.5 centimeter DRH. Okay, suppose if you look at the QP, suppose like let's say this is QP1, this is QP2. Suppose if one can ask the question, what is the ratio of QP2 by QP1? So it could be 3.5 centimeter. So this type of question you can expect in exam. See now in nowadays, if you look at the previous papers, they are not asking to solve the whole hydrograph. They're asking to compute the only peak one. Or sometimes you can expect this type of question. Okay, so that's all. So this is how it looks like. Simply this will be this is a difference. Suppose if you say this is a QP2 and this is a QP1. Suppose if you divide QP2 by QP1, so it will be like 3.5 times. Okay, in this way you can progress. Sorry. Yeah, let's solve one previous year question. So this is a gate. Let me. Yeah, let me interact with you for a while. Yeah. So far, am I clear to you all? You have any questions? Like we'll solve one gate 2019 question. So so this is for a complex storm. Uh, if you have any doubt, you can stop me anytime. Let's solve that question. Yeah. So this is this I have taken from gate 2019 set 3 question number 50. So let's read the question. The ordinates U of a 2 hour unit hydrograph. So note down 2 hour unit hydrograph. Okay, 2 hour unit hydrograph. That is for a 1 centimeter of effector. For a catchment are shown in the table. So they have already given this unit hydrograph values. So, okay, now a 6 hour storm occurs over a catchment such that a rainfall intensity is 1, 1 centimeter per hour for first 2 hours and 0 for next 2 hours and zero point 0.5 centimeter per hour for last 2 hours. So if the base flow is constant at 5 meter cube per second, the peak flow due to this storm will be. So yeah, so see why when you have, when we are seeing this kind of fill in the blanks questions, you must also read. So how many, up to how many decimals you need to round it off, like round it off to 1 decimal. So okay, that you should keep in mind while solving. So let's read what they have given. So they have given one hydrograph, unit hydrograph. Let's say this is a unit hydrograph, 6 hour unit hydrograph. Okay. Now they mention that there is a complex storm which occurred in this way. 0, 2, 4, 6. So yeah, here they have given the rainfall intensity. So how we can calculate the amount value, like rainfall, excess rainfall? Suppose for like a 0 to 2, 2 to 4, 4 to 6. So we need to calculate. This is total, we need to calculate P. So it will be like 1 centimeter per hour into 2. It will be 2 centimeter of excess rainfall depth. Between 2 to 4 hours, they mentioned that 0. So 0 in 0 centimeter per hour into 0, it will be 0 centimeter. And for the next 2 hours, it will be zero point 0.5 centimeter per hour into 2. It will be, sorry, into 1 centimeter. So these are the excess rainfall depth for this complex storm. So it will be like 2 centimeter and 0 centimeter and 1 centimeter. So as I already shown, suppose this is nothing but DRH resulting from 1 centimeter of excess rainfall, isn't it? Suppose when you suppose if there is an excess rainfall of 2 centimeter, what you will do is simply multiply this unit hydrograph with the 2 centimeter. Suppose when this 0 centimeter is there, then again you will simply multiply with the 0 centimeter. Suppose if 1 centimeter means the same. But one point you should remember here, this 0 to 2 centimeter occurred in first 2 hours, and this 0 centimeter occurred in next 2 hours, and this 1 centimeter occurred in next last 2 hours. So there we need to lag. How we'll do that we can see now. So let's go step by step. I have already shown hydrograph. Yeah. So what is a hydrograph? Hydrograph is nothing but graph drawn between rainfall depth versus time. Sometimes you can expect this question also, like match the following: hydrograph, isotopes, like that. So you can expect in this way. So keep this definition in mind. So it will be like rainfall depth, and this will be time in hours. So a graph drawn between this rainfall depth versus time will is gives the hydrograph. Okay. So let's see. This is first column 1 and column 2 is the given data. So they have given the time and the corresponding ordinates. Okay. So yeah, see, look at here. They have given the 2 hour ordinate, 2 hour unit hydrograph ordinates here. Very first step, what we need to do? We need to multiply this 2 centimeter of excess rainfall to this hydrograph is nothing but, so multiply column 2 into 2 centimeter. Okay, that will give this P1 V1, because I have already shown you. Suppose this hydrograph is 1 centimeter DHR. Suppose you wanted to calculate the 2 centimeter, what you will do, simply multiply with the 2. Okay, similarly 2 into 2 4, 8 into 2 16, 18 into 2 36, 13 into 2 64, like that you will multiply all these values. So this is for first. Now this is second, this is third, because they mentioned that there's a complex storm for 6 hours with 2-hour interval. Okay, keep, while solving you should keep these numbers in mind, like what they have given in the question. So now for 0 to 2 we have calculated the P1 U1. Now for how you will calculate for the next one, so what you will do, you will lag these two. Suppose you will lag these two and you will place here. Okay, then how you, what you will do, you will calculate column 2 into 0. Okay, so it will be 0 0 0 0 0, all are zeros. Then again for P3, sorry, this is should be P3, which is nothing but 1 centimeter of excess rainfall. So when we say 1 centimeter means it's the same thing, but what we will do, we will lag 4 hours. We lag 4 hours. So again we'll start with 0, then 2 into 1 2, 8 into 1 8, 18 into 8, all these things in a similar manner we'll get. So this is the columns we get. So how we'll get the total DRH of 6 hours? By summing of column 3, column 4 and column 5. Nothing but suppose 0 plus 0 0, 4 for this thing. So look at here, 90 plus 2, 92, 60 plus 8, 68. In the similar manner we'll sum all these 3 4 5, all these 3. So additionally, what they have given, assume a base flow constant of 5 meter cube per second. So now this base flow will be added to all the ordinates. Base flow will be added to all the ordinates, and which will give the stream flow. Which will give the stream flow. So it's nothing but this. This is a 97 is a final answer. Okay. So what they asked, what is the peak flow due to this storm in meter cube per second? Round it off to one decimal will be 97 meter cube per second. Okay. So let's see what we have done graphically again, once again. Yeah, I can use the here space here. Okay. Graphical understanding what we have done for this question. This is an essential, and after this graphical understanding I'll give this shortcut also how to solve this thing. Let's see. So what they have given, this is 2 over UH. Okay, now this UH has 1 centimeter excess rainfall. The very first step what you will do, you will calculate the 2-hour DRH with 2 centimeter excess rainfall. Okay, so now what you will do, you will lag the unit of 2 hours. Okay, and again you will lag unit of 2 hours. Okay, so now this will be DRH of 1 centimeter excess rainfall. So by summing up all, you will get DRH of 6 hours storm with excess rainfall of total 3 centimeter. Now this is DRH. So what we will do, we will add base flow for it. So it will result, sorry, there is no space here. This is time, this is Q. So this will give the stream flow hydrograph. Okay, now they have asked to calculate the QP value. How much is the QP? Okay, yeah, this may confuse you a lot, because this actually this needs uh, very calm mind, because like see here we're just simply applying the linear relationships. Suppose they have given 1 centimeter DRH, now we need to calculate the 2 centimeter DRH and 0 centimeter DRH and 1 centimeter DRH again. So here we need to shuffle all these terms to get this final value. So let's see how we can solve very simply without doing very big procedure. Okay, so let's read the question once again. Sorry, I think let me see, many have joining here. Yeah. So, yeah, let's see how we can solve. So in the question they have asked to, so they told that they have asked you to calculate this peak flow due to the storm. See, if you see all the previous year questions, they typically ask you to calculate the peak flow only. Okay, so how you can do this peak flow with by avoiding this very big procedure is that we'll see how we can do. So in this question they have given this 6 hour unit hydrograph. Okay, 6 hour unit hydrograph, sorry, 2 hour unit hydrograph and a 6 hour storm. Okay, carefully look at it, and they told that the rainfall intensity is constant for a 2 hours, 2 hours. Okay, so then they ask you to calculate the peak flow. So now what you will do, you identify the, let me put into the screen this more. Yeah, so what you will do, very first step, you identify the peak value in the UH, which is nothing but 45. Let's say this is U5. U5 will be 45 meter cube per second. So this is a peak one. Okay. Now what you will do? Okay. Then so this 45 is one. So what they mention, for 2 hours this unit intensity is constant. So take U3. Take U3 will be 18. Next again take U1, which is 2. Okay, simply what you will do, P1 U5 plus P2 U3 plus P3 U1, nothing but 2 into 45 plus 18 into, sorry, 0 into 18 plus 1 into 2. How much? 92. So this will lead to DRH plus 5, which will give 97 meter cube per second. So it can be solved very one in one line. So, but the tricky point is that sometimes they without giving one, they may simply give 0 to, means that 0 ordinate and a 2 ordinate, 4 ordinate, 6 ordinate, like that.
Sir, why plus 5 is added?
Yeah. So this 5 is for the base flow. So they in this question they have asked you to calculate the stream flow hydrograph. Okay,
Yes, sir.
okay, that one. Otherwise, if they ask you to calculate only DRH, then it could be 92. But they ask you to calculate the stream flow hydrograph, so that you will add 5. That will be 97. Okay,
Sir, you have we selected as a peak value.
correct. So
Why
why I have
Q3
selected?
we selected?
No, sorry.
Q3 how can we choose Q3?
Correct.
Why don't
Yeah,
we
I'll tell you
go to
why I have taken
Q5?
that. Yeah, I'll tell you. See, in this question, what they mentioned is that for first 2 hours, this rainfall is constant. Huh?
Yes,
And the next 2 hours, like that, they have mentioned 2 hours. Okay,
okay.
so that's why once I took the peak one. So I'll detect two and I'll go to the previous one. So graphically, how you can understand? Maybe I should have a bigger slide. Okay, let me put graphically how you can see. This is nothing but QP DRH. So this essentially this sum, and this sum we are doing. Okay, because you were lagging it here. So like that you will perform. Okay, so it will result to the very big one. So this is our interest. Okay, suppose in case if they don't give this fifth one, let's say they give sixth, like as I mentioned, zeroth ordinate, two ordinate, four ordinate, six ordinate, even the same process will hold. So observe the peak one, and from there you subtract the intensity, how much, whether 2 hours or 1 hour, so that you will get the next ordinate. Okay, am I clear?
Yes, sir.
Thank you. So this is a very long procedure, so one can avoid this procedure by knowing this trick. So how you can do, like yeah, okay. So that is corresponding to that is all about assumptions and the theory. So what are the concerns related to the assumptions of unit autograph? So one is that we assume that excess rainfall has a constant intensity within an effective duration. So it may be valid when we go for this long duration events, like a 6 hours and 7 hours, like that. The excess rainfall is uniformly distributed throughout the whole drainage area. Suppose if you are looking at the Ganga basin or Godavari basin, which has spread over 1,000 kilometers or lakh kilometer, like 10,000 kilometers. In these cases, uh, there are subsystems which are responsible for the rainfall. In this case, like, the excess rainfall uniformity is invalid. It's been violated. So, and as well as the base time of DRH resulting from excess rainfall of given duration is constant. Okay, so this third point actually is interest for the researchers. Suppose if you see this Uttarakhand floods 2013 and other floods, so these floods was resulted from the landslide and the deforestation. So there was so much excessive development in the river banks and other areas of the catchment. So in these cases, the response from the catchment would be much different from the past. In this case, in this situation, even though if the same excess rainfall happens, the direct runoff hydrograph seems to be different. So these three violates, these three are in this case, this third assumption will be violated. The ordinates of all DRHs common base are directly proportional to total. Yeah, this is also same. Suppose if there is a significant land use change or any urban development, in these cases all these assumptions will be violated. Okay, so I'll stop here.